Hello, everyone, and welcome to Chapter 12 of our ISCI course over air pollution, climate change, and ozone depletion. So let's go ahead and get started with that. So, what is the atmosphere? You've probably heard the term atmosphere thrown around a lot, talking about the depletion of the ozone layer and things like that. But the atmosphere overall is just a layer of gases and things that float around above the Earth, significant miles above the Earth, anywhere to about 30 to 40 miles above the Earth's surface. You will find the atmosphere from pretty much right above the surface to way up there into space. You will find different layers of gas and different consistencies and numbers and amounts, concentrations, and things. That do really good things for the Earth, and without them, we will have a significantly harder time on our planet. These are the different layers of the atmosphere, but the one that's most important for us is the stratosphere. It sits about 12 or 11 to 30 miles above the Earth's surface. That's the range it runs from, and that's where 95% of the UV rays from the sun are going to be filtered out, and you can see that there. The ozone layer sits right at the bottom of that, which is the end layer of the stratosphere. So the ozone layer is really a big deal to kind of separate the troposphere, the layer down from us, and the stratosphere, the one that does the filtering for the UV rays. And when the ozone layer has a hole in it, it's easy for the UV rays to go straight through. And those UV rays cause damage to our DNA and the living organisms that they touch and that they hit. And things like that. They also warm the Earth's surface, so not particularly great things that UV rays do. Well, anyway, there's a difference between climate and weather. A lot of people think that, it snowed outside, that must mean climate change is fake, and it's like, oh, okay, cool, you have no earthly idea what you're talking about, because climate and weather are two different things. Climate is the weather patterns of a given area over a really, really long period of time. Whereas weather is what's happening right now, or maybe tomorrow, or maybe next week. That's weather. And weather varies very quickly, whereas climate is a consistent thing that you can look at patterns of. So the climate for the summer is usually hot kind of thing. Whereas I can remember when I was a kid, we used to have way more snow than we used to now here in Middle Tennessee. So that's something I can notice has changed. But overall, we're starting to see patterns of climates and things change throughout the globe as our atmosphere warms, as the currents that move around the Earth warm up and change, and the currents that move around in the ocean heat up and change. It carries heat and patterns with it, or heat with it, to different areas. So where it's supposed to go, the heat in that area, the deserts and things are adapted to it. But when it moves, because of what we're doing now with global warming and things like that, the air shifts around, it moves. So now areas that aren't traditionally supposed to be getting a lot of hot air or a lot of warm, dry ocean air are now getting that. So it causes the areas to change in the geography that's found there, and the animals and environments that are found there when a new climate comes into play. Air pollution is also a huge disturbance. What is air pollution, and where does it come from? Well, air pollution is just stuff that's floating around in the air that's not supposed to be there. And it can come from natural or human sources. We could cause it to be disturbed by creating power plants that burn coal and release the coal fumes into the air, or motor vehicle sources, pumping out exhaust fumes and things like that. But there's also natural sources of pollutants. When the wind blows, it blows up dust, and dust is considered a pollutant. Wildfires and volcanoes release ash and things, carbon into the atmosphere, into the air. And then plants release some compounds that are considered pollutants as well. But nature has evolved to deal with its own pollution, not ours on top of it. So that's kind of the problem. We produce way more pollution than nature is used to and is capable of cleaning up quickly. So that's kind of the problem. So here's a couple of big sources of CO2, what they are. What happens to them when they get into the rain? They produce acid rains and things like that that are going to have to come down on the earth at some point in time. And those compounds tend to have other problems as well. And we'll get into that in a little bit. Lead, wonderful thing of lead. The lead has been used for everything. Somebody check out lead, paints, lines, water lines, pipes, all kinds of stuff. And the fallout of lead as it's become a toxic contaminant or pollutant. Just because you remove the lead pipes doesn't necessarily mean that the lead's gotten rid of. It's also in coal. So burning coal power plants can release the lead that's held inside of them into the environment. So a couple different sources of lead and where we get them, and then what we as society could use to stop that, and then how we can control that and fix the problem later on. So burning coal is a really big deal right now. The United States is kind of cutting our dependency on coal now that we have a new president, or at least supposedly. But we're not the only country that uses coal for making power plants. China, India, the quickly developing countries in the world, or a lot of the old Soviet bloc countries, still use coal-fired power plants. They're cheap. There's a lot of coal in this area. They're dirty. They produce enough energy to power stuff. So if you need to get one down fast and running while your country's developing, that's the thing to go for. And that's what tends to happen. But they need a lot of them because they have a lot of people and they're growing very quickly, so they're burning lots and lots and lots of coal. And that coal contains sulfur and lead and all kinds of other fun chemicals that when it's released and burned, it goes into the atmosphere and then concentrates there, and then it causes lots of problems with breathing and inhaling all those chemicals and things. And then the chemicals can concentrate on stuff in the ecosystem as well. Outdoor pollution. How do we reduce outdoor air pollution? Well, naturally speaking, things just settle. Or how does nature, deal with this problem with air pollution? Things just naturally settle due to gravity. Well, as things settle due to gravity, they're going to sink out of the air, and then whatever they're carrying with them is going to be stuck there now. So if their substance was toxic or dirt or anything like that, that's now stuck on that area. Rain and snow do the same thing. Acid rain, acidic snow. That's not fun. Salty sea spray from the oceans can knock stuff down as well. The moisture can carry it, but then that contaminates the ocean. Winds, blowing things away, that's easy. It just moves from place to place. And then chemical reactions can occur, which technically clean, I guess, parts of these pollutions. Things like O3, ozone, and stuff like that can occur. But lots of our activities also can lead to increased outdoor air pollution. Building buildings, destroying the trees that were originally there. Lots of that stuff can do that. High temperatures, it makes winds blow more. It also makes things harder to fall out of the air for gravity, so it keeps things floating around. Lots of different other things that increase outdoor air pollution. And when we as humans or other animals have to breathe this air that's full of things that are floating around in it, toxins and pollutants, it causes problems with our body. We are evolved to have protection from things that we inhale. Nose hairs, the cilia inside of your respiratory linings, the mucus and snot and things like that, sneezing, coughing, all designed to keep stuff out of your respiratory system in mass numbers. But when air pollution is high, your body gets overwhelmed. There's not enough it can do. It can't clean enough to get rid of all of the bad air because there's just so much of it. And if you smoke or have exposure to this prolonged bad air, places in China and things like that, people are having problems with it. It ends up with the exact same effects: chronic bronchitis and emphysema. Your lungs are permanently damaged. They have scar tissue in them. They have a difficulty taking in oxygen. And smoking and these high pollutants essentially cause the same thing: particles of junk in your lungs that cause damage, and that's not a good thing. So 3.2 million deaths worldwide from air pollution. There's probably more now. Most of them are in China. It's because of how their government burns coal for their power plants. That's what happens. As you can see, the deaths per 100,000 in the United States concentrated around coal country. most of the places where we have burning coal burning power plants, West Virginia and places like that, tend to be where it's concentrated. So acid rain is another big one. When we pump these chemicals into the atmosphere, they go up into the atmosphere. They come in contact with water vapor, and then that water vapor, some of the contents of those chemicals and things that are in the air that have been burned or whatnot released will bond with that rain, forming acid. And that acid is very dangerous. As it rains down onto the earth, it's obviously raining acid. Can cause lots of different problems throughout the world. So somebody check out the problems with acid rain. It's a really good discussion topic. The different things that acid rain does to our environment. There's a couple of ways that it gets into the environment. Burning coal, for one. Natural gas would be a great alternative for that. Lots of different ways to minimize the effects of acid rain. Indoor air pollution is just as bad in some places. People that smoke indoors, formaldehyde used in the production of carpets or laminate flooring, all kinds of different things. Those chemicals will leach out. They don't stay in the carpet. They will, they get aerosolized as you walk on them and things like that. So you're breathing in formaldehyde and things that are in your carpet. In the paints, some places have radon gas that's floating around in the environment. All kinds of fun things that are indoor air pollutions that you have to deal with as well. That are exacerbated by the fact that we use horrible things to create the life around us, and we don't much care what happens to it after it leaves the factory, kind of thing. So here's some sources of indoor toxins and indoor pollutions that you have inside your own house that can contaminate the air. So check those out. Air pollution, it's a big deal. We all have to breathe the air. The United States has passed multiple laws, multiple acts to try to clean up the United States overall, to try to encourage the decrease in coal power plants and things like that, to kind of increase or decrease the dependence on coal, where we have more breathable air and less smog and stuff floating around in our big major cities. So we can do a lot to stop this. Mostly it's just going to take money. Teaching people what the effects of these things are, and then offering them some sort of economic incentive to do something better than what they're doing now. So that's a really good idea. Just teach people and give them the ability to clean up outdoor air pollutants, to not burn coal power plants, and we need to come up with something better for our cars than the exhaust and things like that. So if we do this will cut down acid rain. This will cut down the destruction of the ozone layer. Lots of good things would come from this. Outdoor air pollution, once again, we can cut down the reliance on cars. But in developing countries, that's a big deal, and that's kind of hard to do. People are now getting economics where they're able to move up from being able to having to walk everywhere, maybe ride a cow or something, or a donkey, and now they have their own car. And when they do that, they're going to drive everywhere they can go. And that creates more and more and more pollution, more and more congestion, and they probably don't know how to drive. I doubt the countries have the best infrastructure for driving, so all of that leads to more and more pollution problems. Places that are developing will also produce their own cars, so somebody check that one out for discussion topic. What happens when developing countries produce their own cars? So check that one out. Once again, ways to fix our problems of over reliance on fuels and creating too much pollution and things like that. Indoor air pollution, you live in your house most of the time. At minimum, you're sleeping inside your house probably about 7 to 8 hours a day. So you're breathing in that air that's been polluted inside of your house. So what do we as a society need to do to clean up the air for us inside of houses? Lots of stuff. You can ban indoor smoking. We can create different laws for making carpets and making furniture and things like that that regulate the use of those chemicals. All kinds of different stuff to help regulate the quality of indoor air particles. And we had those problems in the United States. It's not just developing countries that have these, but it's significantly worse in those particular places. You also have to think about the fact that if you have a wood-burning stove in your house, most of the world burns wood for heat. That's also a lot of pollution. So people with burning stoves, you're breathing in some of the smoke. So imagine if you just have a wood burning fireplace or something that's just open in the middle of your floor, like they might in South America or something like that, or Africa, India, and you can imagine what the pollution that those individuals would be breathing in would be. So how do we fight this problem of rising temperatures and things like that? So climate change is not a new thing. Um, we have watched it throughout history for about 3 billion years using the fossil records and Arctic ice cores and things like that, that we'll talk about in history or in lecture in class. But those are natural sources, and in the natural sources, they don't skyrocket quite as fast as we're seeing now. You see a very gradual increase of temperature, very gradual increase of carbon and things like that in the atmosphere. But now we're seeing pretty much this. It just goes straight up due to our activities. So human activities are kind of not helping this natural process slow down any. And once we hit the gas pedal on it, it's going to get worse. Greenhouse gases, you're probably familiar with this concept. When we release things into the atmosphere, carbon dioxide, methane, nitrous oxide, water can even be considered one of these. It goes up into the atmosphere, and when it goes up into the atmosphere, the heat rays that bounce off the earth are going to hit that, they're going to bounce right back down. So it just creates a compounding cycle of heat bouncing up and down from the atmosphere to the earth's surface. And when it does that, the heat would naturally just be going up into the atmosphere, being gone, lost into space. Now it's not. And that causes the earth to become warmer as the temperature hits back and forth off the surface. It causes the natural warming of the earth's surface overall, and that's not a good thing. So since the Industrial Revolution around the end of the 1800s, we started to burn fossil fuels, coals, and things like that, which release lots and lots of carbon dioxide into the atmosphere, and that's essentially what's hit the gas pedal on our pollution problems, on the fossil fuels causing greenhouse gases to be produced, and then the global warming, rising up to global temperatures overall, altering of the jet stream, all kinds of other fun things are correlated with an increase of CO2, which traps the heat, bouncing back and forth around inside of the atmosphere. So a bunch of things that could happen due to the proposed, using climate change models. Let's talk about these in lecture. These are some good ones. How do we fix this? There's lots of options. Stop or reduce. That's pretty much it. There's lots of options is in lots of different proposed ways to do this, but essentially they all boil down to stop doing this or reduce doing that. And then you have the mitigate approach, which is, just work around it. As the sea levels rise, we have to work around that. And that's, not a fun one either. We can get away from using fossil fuels, renewable fuels, water, hydrogen fuels, solar, water fuels, things like that will help a lot on this one as well. And also we can just stop cutting down the rainforest and plant some more trees, which will clean the atmosphere for us, and that's a good thing too, produce more oxygen and CO2, so that's a good thing. Carbon sinks. Let's talk about carbon sinks in class. Really interesting concept, what a carbon sink is useful for, and some of the problems with carbon sinks. Lots and lots and lots of governments are doing things to deal with these problems, to pledge to reduce carbon emissions and things across the world. The Paris Climate Accord that we left and now we're back in is another one that we should definitely talk about in class. So Costa Rica has kind of taken this by the horns. A very small country, which allows them to do this. There's not a lot of people, which also allows them to be able to do this stuff. But if you think about us in places like China and India, we're very large, we're very individualistic. We have a lot of different people, a lot of different areas. So it's not quite as easy as just saying everybody in Costa Rica is going to be carbon neutral, because there's not a lot of people there. It's a very small country. It's easy to do. Not so easy in large developed countries. Here's what you can do on an individual basis to deal with your individual CO2 emissions. We'll talk about this in lecture. We can prepare for climate change, move away from the oceans, put buildings on stilts or with water lanes and things like that. Start stockpiling key food sources. in case droughts become more common and things like that. Make crops that need less water, so as droughts become more common, or start irrigation processes that are way more efficient, so the water that we do have is not just wasted. So there's lots of ways that humans can help prepare for the downstream effects of climate change, which are inevitably going to come. So let's talk about the ozone layer in class. CFCs, fluorocarbons, carbon fluorocarbons, those are fun. So let's talk about those in class. And maybe ask your parents about the use of hairsprays and things like that when they were kids, and what happened when those were banned. So if the ozone layer goes away, essentially what's going to happen is all of the UVA and UVB rays that it filters out for us are now going to hit the Earth's surface. And when they hit the Earth's surface, you're going to get a sunburn, you're going to get cancer, you're going to get cataracts in your eyes. It's going to cause things to get hot, and that's not fun. So essentially just walking outside would cause cancer if there was no ozone layer. And that's not good. And it also destroys organisms that live in the water that produce oxygen for us. Little phytoplankton, algae, things that make the food chain float around, make it work. It kills them. The UV rays will kill them. It destroys their DNA. It damages their ability to produce energy via photosynthesis. So once that goes away, everything else kind of goes away too. So we can fix this. The ozone layer will start to recover. It takes a really long time. We can start to see the hole that we created in the 60s and 70s start to close ever so slightly now. So once again, here's our 3 big ideas that we'll definitely talk about in class here. So make sure that you're putting some good thoughts and things and coming with some good discussions over what you can do as an individual about climate change to reduce your impacts, or what governments can do. So let's just come to class with some good discussion topics over climate change. If you want me to elaborate on anything on this, guys, just let me know, shoot me an email, and I'll be happy to. If not, have a good rest of the day, and I'll see you in lecture to talk about the rest of this stuff.